So what I did was I went out on the internet and I found a project I would like to build. I just wanted to show you the website where I got the idea for the Simon-based game. It comes from talkingelectronics.com and it was originally programmed by Keith Wilson. If you scroll down the page, you can see that they give you the files that you're going to need. So there's the Simon F84.asm file and the Simon F84.hex file. So the hex file is what you load onto your IC using a PIC programmer. I use the Pic16F84. As you scroll further down, you can see they give you the schematic for the Simon circuit. Now they're using a 3-volt supply, so two 1.5-volt batteries, and they step it up using a transformer to get to 5 volts. I've replaced this circuit with a 9-volt battery and a 5-volt voltage regulator. As you scroll further down, it gives you information about the circuit, how the circuit works, and then they give you construction details. And you can see they have a printed circuit board, so you can actually purchase this kit from them. If you go over to their second page, they give you the program, and you can see the program for the Pic16F84A is written in assembler language. So in my case, I just loaded in the hex file onto the IC. The second piece of software I want to show you is over here. It's called Do-It-Yourself Layout Creator, and it's at a website called diy-fever.com. And you can see here that this is the software that I use to do the layout for the Perfboard. So if you're thinking of doing any Perfboard layouts, this kind of software will help you. And I have it built here on a breadboard, and I've got some LEDs and some switches, and I've got an IC here that's the PIC chip that's programmed. And when I power my circuit, you can see that it works fine, and the gameplay seems to be working. And when I get it wrong, it tells me it's wrong, and then shows me what it should have been, and then starts over again. Now, putting it on a breadboard like this is kind of clumsy, so the next step would be to build it permanently onto another piece of board. So I really don't want to take the time to design a printed circuit board and etch it and go through all that. So the next thing that I might want to build it on is a piece of Perfboard, and Perfboard just has a whole bunch of holes in it, and I can just mount my parts and solder them in place and make the connections manually. So I'm going to show you how to do that in this particular project. So this is the package for the 2015 PIC-based Simon game. Before I go over the parts with you, I just want to go over the marking sheet. For the PIC-based Simon game, the total number of points is 30, so this project is worth 30% of your grade. As usual with my projects, keeping the sign-off sheet clean without any stains or wrinkles is worth a mark. The board mechanical, that's drilling holes and affixing the speaker to it, that's worth 3 marks. The soldering of your components is worth a total of 8 marks, broken down as no unnecessary solder on the board, all joints fully soldered, no excess solder on component leads, no missing solder pads. Please note that if you do not clean your board of the flux, you're going to lose 2 marks. Cold solder joints, that's where the solder is not shiny, you're going to lose a mark for each of those. And shorts or bridges, obviously if you have any of these, your project's just not going to work. Component placement is very important on this project because if you don't get the parts in the right place, you're going to have trouble making the connections. So that's worth a total of 12 marks. And it's broken down as all components flush with the board. You get a mark. Center your components between the holes. Another mark. Orient all your resistors and components in a consistent manner. That's another mark. Trimming your leads correctly. Another mark. Placing the components properly. 4 marks. Placing the jumpers. They go on the bottom of the board, and they're to be bare wires, so that's 2 marks. And jumpers on top of the board. Now they're supposed to be insulated, so we want them straight, no wrinkles, and we don't want them melted, so that's worth another 2 marks. Completed assembly is worth 6 marks. So if the audio is working, sound's coming out the speakers, that's worth 2 marks. All your LEDs flashing and blinking, that's worth another 2 marks. And if we can actually play the game on your finished projects, that's another 2 marks. So you don't get very many marks for making it work, but you do get a lot of marks for neatness and soldering. As always, we're going to have a deduction for each part that you're going to need. So if you start breaking leads off of parts, they're going to cost you marks. And remember to get all your signatures on the sign-off sheet. Please note at the bottom there's a note and it says any project submitted for grading without the mandatory sign-off sheet will result in a grade of 0. So sign-off sheets placed in your file folder will result in your project being graded. So this is probably going to be a 2 or 3 week project, so you have to keep this sheet at home, neat and clean, and bring it into your lab. On the mandatory sign-off sheet, you can see the first sign-off is by you to ensure that your kit is complete before starting the project. The next sign-off is for having your perf board engraved. The next sign-off, we have to drill some holes, and they give you a hint. The push buttons, the power jack, and the regulator. They all have oversized leads, so you're going to have to drill your board so those components will fit. There's another sign-off to be checked when your PC board is populated by some components before soldering. So we want at least 4 to 6 components. And we want to see the IC, the socket, the regulator, the power jack, push buttons, just to make sure that those holes are drilled correctly. And you might want to throw an LED on there so that we make sure you get the polarity right. So starting off with sign-off part E, that's when you actually do the soldering. So everything before then was no soldering. So now we're going to check. We want to see at least 4, no more than 8 components, so that we can give you feedback and tell you how you're doing with your soldering. F is when at least 4, no more than 8 connections. So E was components, F is connections. So that's making connections between pins and components. So we can give you some feedback on how you're running those jumper wires. Then G is demonstrating your Simon circuit operating correctly. So we want to see sound, lights, and gameplay operating correctly. As with all my other projects, I give space here for the replacement parts that you needed. Hopefully you won't need this many replacement parts because you're losing 2 marks per part. There is a warning here that all projects must remain in your project box until graded. Violation of this policy will result in a grade of 0. So we don't want you on the first week taking this home and perhaps you have an uncle who's working in the industry and he does all the soldering for you. That wouldn't be fair. So keep your project in the project box, and we do check this every week. I've opened up my parts kit and I've got my instructions here in front of me. On the back here you can see that I have a parts list. So the first thing that I'm going to do is I'm going to go over all my parts here. So the first part that I have here is my perforated board, followed by my Pic16F84 chip and the socket to put it in, a piezo diaphragm speaker. So the little speaker is just going to be this little guy here. A 7805. It's a voltage regulator. Basically you can put in anywhere up to about 18 volts, and 5 volts always comes out. And then a 9 volt battery jack or plug, so we're going to use the jack since we've already made a plug for the 9 volt battery cable. Then we're looking for a 27 picofarad capacitor, which will probably be this little guy here, and a 100 nanofarad capacitor, which is probably this guy here. We're looking for 4 10k ohm resistors, so that would be this brown, black, orange. These 4 here. 4 330 ohm resistors, which are orange, orange, brown, so that would be those guys. And 1 4.7k ohm resistor, so that would be this guy here with the yellow band. We're looking for 4 push button switches, so that's these guys right here. And then we're looking for 4 LEDs, a red one, a green one, a yellow one, and this one is more orange. So that's our parts. So this is our PIC-based Simon game, and we're going to power it from a 9 volt battery. So we're going to be using a 9 volt battery clip, so that just snaps onto the battery. The other end, to make it more convenient, we're going to use a 2.1 millimeter power plug that goes into the jack on the Simon game. Now there's a proper way to install the wires onto the plug, so I'm going to give you a separate video on how to do that. Perforated board comes in different sizes. So this is one size. This one would be a larger size. This one has pads on the side to solder things onto. And you know, the color of the board's changed to green. Doesn't really matter. I have small pieces of perf board. And you can also get it in a less expensive variety. This one here is has pads on one side, and it does not feed through the hole to the other side. Whereas if you look at perf board like this, you can see there's pads on one side and it feeds through to the other side. So it doesn't matter which side you solder onto. Here's a little piece of perf board somebody used to mount a relay on. The only problem with this perf board is there's actually no solder pads on it. So you have to poke the wire through and then bend them over and solder to other wires. Also, most of the perf board that I purchase has a pad for each single hole. So this is actually pad per hole. You can also get perf board that has soldered buses in it, as well as single holes and holes that feed through. There's also boards that are called strip board, and all the pads are joined together in long strips, and then you have to cut them where you want them cut. The one thing that all perforated boards seems to have in common is they already have the holes pre-drilled for you. So it makes it pretty easy to do your projects. The part just goes straight into the board. So all you got to do is find the hole, push the part into the board, and then solder it on the other side. Now this works well for most components. So if I take my IC socket, you notice all these holes are already pre-drilled for the spacing for an IC socket to fit in there. The problem is when you come along and try and put the power jack in there, now you have to drill out some slots for the jack to go in. Something like this voltage regulator has larger pins on it as well. While the spacing is okay, it won't go through those holes, so you're going to have to slot those holes so that the voltage regulator can go in. Sometimes you have some diodes that have thicker leads and they will not go through, but most resistors will. And then something like these little push button switches, while the spacing is close, right, the legs will not go through those holes unless they are slotted as well. So I think the first thing that we're going to do with the board is I'm going to engrave my name on it. So I'll show you how to do that. This is my engraver. This is the pointy end where you actually engrave your name. I like to set the setting here about halfway. So on the back here we have the on-off switch. So it does make a little bit of noise. You want to find a spot on the board where there are no pads. So right along the bottom edge here or along this edge here would be a great spot to engrave your name. So all you got to do is turn the engraver on and press fairly hard and move slowly, and you should be able to make out all the letters of your name. So I'm going to turn my engraver on and engrave my name. So there's my name engraved. You'll notice I went over each letter twice just to make sure that it did go through the green layer. Now normally when you're using a piece of perf board, you would like to start by putting the IC in the center because it usually takes up the most room, and then following all the parts off of the leads for the IC seem to make the most sense. Now I've gone out on the internet and I've found that there is some free software, circuit designer software called Do-It-Yourself Layout Creator. It allows you to set up the size of your perf board and then mount all your parts. So it has a standard kind of part library. Some of the things like these push button switches, they didn't have a part for it, so I just put in the 4 pads and then I drew a rectangle and then I drew a circle around the middle and then changed the colors for you. It allows you to put in jumpers so you can see where the jumpers are going to be on the top of the board, and then all these lines here we're just going to make them from the leads of the components. Now I have identified 3 parts that will not fit into a piece of perf board. One is the voltage regulator, and you can see that the legs are a little bit larger than that of a resistor. So the resistor fits into the perf board perfectly, but when I take something like a voltage regulator, the whole spacing is correct, but the pins won't go through the board, so I'm going to need to make some little slots for that. The same thing is true of the push buttons. While the holes are about the right spacing, the legs won't go through, so I'm going to need to slot those holes. And then of course the power jack that we're using, you can see that that's going to need some fairly big slots made in it as well. So 1, 2, 3, 4, 5, 6 hole down, and it's going to go approximately right there. So I need to expand, right? I need to slot that hole right there. So in order to keep it, I'm just going to color it in with a little marker so I know that that's the hole that I've identified. So that's going to be my starting hole. So then when I put the component in, I can see that the next hole has to be just between 1, 2, 3, 4, just between 3 and 4. So I'm going to have to make a hole right between there. So I'm going to take a scribe here. This is a machinist scribe. And I'm just going to use a hammer and tap it lightly. That way I know that I need to start drilling down here. Now I need to make a slot. So in order to make a slot, I'm going to punch a little hole on either side. So right on that join there, and one over here. And then I'm going to do the same thing for this hole here and on the other side. So what I've done is I've identified this hole as being the center of the front connector, and I've punched a hole on this side and one on this side, and then I identified this spacing between this hole and this hole is where I'm going to put my slot. So I've punched 3 little holes in a row there, and now I just need to find out where the side piece is going to be. So taking my part and sticking it on here, it looks like it's going to go in this center hole right here, so one back. So then I want to make a slot here, so what I'm going to do is I'm going to go, it's just one hole back, so it's the line separating the 2 holes, and then the line separating these 2 holes. So you probably can't see it very well, but I've identified this hole as being the center of the side tab, and I've punched a little hole on the line here between the 2 holes, and I've punched another little hole right here on the line between these 2 holes. So now I'm going to drill out this hole and this hole, and then I'm going to put my drill bit down there, and I'm just going to rock it back and forth until I've cut a slot between those holes. Next thing I need to do is identify where I'm going to put these little push buttons, and I'm looking at the layout that I did, and I can see that it's 1, 2, 3, 4. So I'm going to punch a hole there just so I can see where it goes, and then I go 1, 2, 3, 4, punch a hole there. So that's going to be where my switch goes, from that hole to that hole. And then I've got 1, 2, 3, 4 holes over. So 1, 2, 3, 4 holes over. So that leaves 2 between the switches. So 1, 2, 3, 4. So it looks like I leave 2 holes, then punch a hole. So there's one switch. It goes in there. There's my next switch. Goes in there. Then my next switch goes in there. And then my last switch goes in here. So it looks like I got the spacing correct for the switches. So I'll take those out. And remember, you want 2 rows of holes, so do the one above it. Right, so the holes are already drilled in the board, but using that machinist scribe in there opens up the hole a little bit more so that you can actually see where you want to slot it. Now the next part I have to get in here is the voltage regulator, and that needs to go, it's going to go with its last leg. It's going to be, let's see, 2 holes behind the jack. Right, so that's where the jack's going to go, and it needs to be 2 holes behind the jack. So if that's the jack holes, it's got to go 1, 2 behind the jack. So it's going to go right there. So it's going to be that hole, and that hole. Always count your hole spacing over from the edge of the board. If you count from previously placed components, you're just going to compound your errors. So for the voltage regulator, it needs to go 6 holes down, and that first input pin should be 6 holes over. Okay, so now I've identified which holes I need to make larger. I'll show you how to do that on the little Dremel drill presses that we have here. This is my Dremel tool. Dremel's a brand name. It's in a drill press. This is the handle for the drill to go up and down. This is the control for the variable speed, which you probably want to set about halfway. This is the chuck. It's a keyless chuck, so you can screw it and unscrew it with your fingers. So the spindle doesn't move when you're trying to screw it and unscrew it. You press the little lock button in, and that will lock the spindle in place. To adjust the height, there's a control on the side here, so if you unscrew it, you can actually slide the whole unit up and down. So to make this video, I've taken the Dremel drill off of the drill press so that I can show you a close-up of the chuck. There's the lock button, so you can put your finger on the lock button, and when you rotate the chuck, okay, you can see that the 3 little fingers that were in there went back inside, and when you turn it clockwise, the 3 little fingers come out. Now we use 1/32 inch drill bits. They're approximately the right size we need for all our components, and they're fairly common to find in any of the hardware stores. So the goal is to place this drill bit into this chuck, and we want to get it right in the center. so that the whole thing rotates around the axis of the drill bit. So putting it in here, you can see that the drill bit actually slides between the fingers. So we need to tighten it up a little bit first, and then place the drill bit right in the center of the 3 fingers. And we don't want it to wobble all around, so you may need to tighten a little more. Okay, so we want to place the drill bit all the way back to the cutting edges. We don't want it all the way down the end here, because then the drill bit will flex, and if it flexes too much it'll break. So you want to get it back as close as possible to those cutting edges, and then turn it clockwise to tighten it up. So when you've got it tightened up, you can let go of the lock button and then twist and see if it does indeed turn along the axis. To take the drill bit out, all you have to do is press down on the lock button and turn the chuck clock counterclockwise, and the drill bit should slide out. So the first thing I'm going to do is drill out those holes. So I've drilled out the holes for the slots for the power jack. So now I've got to turn them into slots, and I'm going to do that by putting it into the drill bit and then just rocking the board gently to open up those holes. So now you can see I have a slot across here, a slot up and down here, and a slot over here. Now the other ones, I just need to make small slots. So I'll start with the voltage regulator. Then you can come along and check your component to see if it does actually slide in there. So there's my voltage regulator, and that seems to slide in okay. Now I'm going to do all the switches on the right, these little push button switches. Now you have to remember which way you want to slot them, right? Because you don't want to put the slot in the wrong way. So this will be back and forth. So I'll do all those switches now. Once you're done drilling them, you should check and make sure that your parts do fit in there. So I'll check the first push button switch, and you might need to spread its legs just a little bit to kind of help it get in there. And then when you push it in, it should be flat. Right, you want to get it as flat as possible to the board. So check all your push buttons, and don't forget to check the power jack. Make sure that its slots were cut big enough. If they're not, then you're going to have to go back and drill it again. So this front one's still a little bit stiff, so I'm going to go back and do it. So let's give it another try. Okay, that seems to fit in okay. So I've got all my push button switches all on the board, and they all sit nice and flat. I've got my power jack there. Now what I like to do with these voltage regulators is I don't want them taking up a lot of board space, so I bend them right back here. There's several ways to do this, but what I like to do is I like to just use the bench, and I just fold it back on itself, bending all the legs together. That way you're not bending them individually and breaking them off. So there you go, it's in a nice little L shape, and that should fit into those holes as well. Okay, so once you've put parts in the board, do not cut the leads off underneath, because we're going to be using these leads to make the connections. Now, looking at the layout that I've provided you with here, the tab on the voltage regulator actually comes to hole number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's supposed to stop at 11, and your socket goes in at 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, so, and the socket goes in at 12. So you can see that the way I've bent my voltage regulator, it actually goes one hole further back than the diagram shows. But that's okay, because I left some leeway there before the next capacitor and the resistor goes in. Also make sure that it is indeed, right, 1, 2, 3, 4, 5, 6, 7, 8, 9 holes back. So I've got it 1, 2, 3, 4, 5, 6, 7, 8, 9 holes back. So it's in the 10th hole. Okay. And remember that your socket is polarized, so you want the little smiley face is this little indent down here at this end of the socket, so that when you put your chip in, you'll be able to orient it from the socket. So now that I've got these major components in, I would probably solder them into place right now. Typically, if I was doing a printed circuit board, I would put the lower or flat parts in first, like resistors, diodes, that kind of thing. But in this case, I put them in last because I need the resistor and diode leads to make all these connections that are shown here on this board layout. Now, before I start soldering components on the board, I just want to bring your attention to this line here. Right, this is going to be your common, and this line here is going to be your power, right? So when the 9 volts comes in, this will be the black line. And you notice the black line goes to each of these LEDs along here, and then I brought it along the other side here and comes down and seems to go to all the resistors on this side here. So it's common for a ground to be run all the way around the outside of a board. Now when you look at your board, One of the things that you're not going to notice right off the bat, but when you're looking at the solder pads here, you'll notice in the top corner here it's labeled GND, and on the other side here it's labeled VCC. And on this particular board, all these pads are single pads and they're not joined, but this outer trace all the way along to the other end where it says GND is joined together, and you can check that out with an ohm meter. And if you look really closely, you can see a line sort of going through there, but it's really hard to tell. So you wouldn't know that unless you checked it with an ohm meter. But I happen to know from previous experience that that line there that's labeled GND goes all the way down, and this line here that's labeled VCC goes all the way down. So when you're looking at the part layout that I gave you, right, this line here is already on the board for you, so you don't need to put wire across there. But from here down, you'll have to put a piece of wire in, and all along this outer edge here, we'll need a piece of wire going across it to join one side to the other. But all these connections down here to the resistors, they're already made for you with this particular board. So I'm going to start putting some components in my board, and I'm going to start with the power jack. One of the things about the power jack is some of these pins went between the lines of the holes, so I've got to bridge the solder over to the pad, because now all these pads, right, are individual. And if you were making a printed circuit board, you'd make one pad for the pin, so it'd go all the way around the pin. But here it's going across several pins, so it's going to be a little bit tricky trying to solder those in. So I'll try and show you that now. So when you're soldering parts in, you want to keep them as flat on the board as possible. If I was to just solder this in, right, it could go on a bit of an angle and leave space on the board. So you want to make sure you get these parts in as flat as possible. So put them on a solid surface, and what you're going to do is just solder in one pin at a time. Don't solder in 3 pins and then check your work. So you'll notice I'm going to be using the conical tip, or the pointy tip if you like. And what I want to do is I want to put a little bit of solder on my tip to aid in the heat transfer, and then I'm going to put my tip down on the board, heating up both the pad and the component, and I'm going to put some solder in there and then take my tip away. Now I haven't got solder all the way around it, but what I'm going to do is I'm going to check and make sure that my component is flat on the board, and then I'll add some more solder and try and bridge across from some of the pads to the pin that I've got in there. So a little bit of solder on the tip, then bring the tip in, and then put some solder on the other side, and then take it away. It's going to be very hard on these pins to get a concave shape, but you try and do the best that you can. Right, all these push buttons that we put in, we had to make little slots for them. So when you look at the pin on the back side, it's going to be somewhat difficult to get a nice smooth coating around it, but you try the best that you can. So let's take a look at one of those. Put a little bit of solder on your tip, heat up the pin in the pad, bring the solder in from the other side, wait for it to melt, then take your tip away. So now I'm going to put in the voltage regulator, and when you solder these parts in, you have to make some connections. So when you take a look underneath the board, you can see that this voltage regulator has some fairly sturdy pins on it, and we can use those to make some of the connections. So looking at the part layout that I've given you, you can see that the first pin on the voltage regulator has to come over and join with the power jack. so you can bend that first lead over and make contact with the power jack. So push your voltage regulator in, turn your board over, and you can see that this first pin needs to be bent over until it makes contact with the voltage regulator. Now you can see that this pin goes over past the tab of the voltage regulator, so this is where you take your side cutters and you trim it off. So just get your side cutters in there and trim it off just about where the tab is. Okay, so now when you press this pin down, you want it to melt into the solder that's on the tab, and it'll make an electrical connection for you. Now what I've done is over the last 2 weeks I've grown my fingernails a little bit longer than I would normally have them, so that I can use my fingernails to push those in. If you use just your finger, you're going to burn the fleshy part of your finger. So if you have really short nails, you're going to need a tool to press on that at the same time you're heating it up. So I've got my nail on the leg of the voltage regulator. So now I'm going to bring my iron in. I'm going to reheat that pin. Push the pin down and let go. It's very important to keep hold of the pins that you're trying to solder together, because if you let go, they're just going to spring back. So when you look at it, right, you can see that that is a fairly good connection, and the voltage regulator is now soldered to the board. You can now go back and solder in this pin here, but remember to not overheat it, because the heat's going to transfer the length of the entire pin, and it could heat up this connection and then just bounce free again. So what I've done so far is I've made this connection right across here. Now what I'd like to do is I would like to do this connection. You can see it bends down and goes over, and then on the last leg it bends down and goes over, and then down and around all the way over to the switch. So obviously the leads are not going to be long enough to make these connections, but what you can do is actually bend these parts over and bend the leads into place so that they start to go in the right direction, and then you can extend them with other leads. So for instance, this one right here, you can see doesn't quite make it over. So what I'm going to do is I'm going to use a piece of wire. So just your basic solid hookup wire. So all I do is I strip the end off. Now you've got a solid piece of wire to work with. Make sure that the end is a nice clean cut. And I don't cut these to size. I'd rather have them a little bit longer so that I can hold them with my fingers, because when you're actually soldering these things into place, they get really hot. So if you have a longer piece of wire, you can get your fingers further away from the heat. So what I'm going to do is I'm going to bring the wire in, and I'm going to overlap it. So it's going to overlap the pin from the voltage regulator, and there's the pin from the power jack, and there's the front end where I want it to go to. So the first thing I'm going to do is heat up the pin on the power jack and just melt the wire into it, and then just hold it into place there. Now make sure it doesn't go too far down the end. You can always reheat it and adjust accordingly. You've got to hold it until it cools, and then you can let go. Now you can solder in the connection at this end. It's very important to get the connection down here. Just heat that up. Okay, so there's my first extended wire connection. Okay, so I've done the first connection here. I've done the second connection down here, and I've got the wire dangling off the screen here. So now what I want to do is I want to go up and make contact with the next one, and then I want to go up to here, and then I want to bring it through the board and jumper it over. It's worth noting here that the layout that I gave you is the top view, and you have to remember to reverse all these dimensions on here when you're looking at the board, because the board is the bottom view. So you're really looking for my layout. Right, the pins are going across here underneath, and the next one comes down and goes over to this pin, then to the front pin, and then up to the top. So mentally you've got to kind of reverse this as you're working on it. So the best thing to do is to take your small pair of needle nose pliers and just hold on to the wire here as you try and bend it. And you just bend it around until you get it into the shape and the direction that you want it to be in. So when you've got the wire in place, remember you've got to heat up every joint that you want it to make contact with, and then when you get down here, the best thing to do is to snip it off somewhere around here, slide off the remainder of the insulation. And then when you're at the pin that you want to be at, and in this case we want to be at this very last pin here, we can snip it off just after the pad. Okay, so don't snip it off before the pad. You need it to go just a little bit past the pad that you're going to solder to. So now we're going to put in a jumper wire up above. So these small jumper wires, what we're going to do is we're going to strip it first, and then we're going to see how much length we need to go across the corner, and we can see that it's probably about that much. So then we can cut that off about there. And then what you can do is actually come along here with your needle nose, and you can slide the insulation back a bit and then make the bend. So there's the first bend, and you want to get it fairly square. Then you want to check the size on the board again, so check another corner on the board. And then bend your second piece. So there's my wire with the two bends. So when you've got it all set up for the right holes, it should slide in. And one thing that we want to be really careful of is when we solder these pins, we don't want to overheat the wire, because then your plastic insulator on the top here will melt. So I've got my pin in for the jumper, and then I've got my other wire here. So what I'm going to do is I'm just going to come in with my soldering iron and my solder, and I want to heat up and add some solder in, and then move my tip up. And if I've done that correctly, I should have a good connection there. As you can see, I'm lifting up a little bit off the board here, so you want to get it as flat to the board as possible. You can always go back, and if you've got a long fingernail, you can reheat things and push down with your fingernail and try and get these things flatter. So there's that one. Reheat this one, push it down. Now keep in mind, you've got to keep pressure on it, until it cools. And there you can see we've got it down a little bit flatter. And now I've got to come in and finish this other pin here. So a little bit of solder on the tip, bring it in, heat up the tip and the pad, solder in from the other side, and then lift your tip up. So I think you can see here that where you solder a pin to a pad, it makes a really good connection, and you have a little bit of trouble where you're trying to hook a wire into a pin and a pad. So once you've got these in and you're happy with them, you can just trim them to the top of the solder joint there. And remember what we said, once I've brought the ground in to this first pin, it's going to run the entire length of this bus line here. So I've gone ahead and I've put in my jumpers. I've got one little jumper here, a little jumper down here, and a little jumper over here. I've soldered in my 2.1 millimeter jack for the power to come in. I've soldered in the voltage regulator. I soldered in all the pins for the IC socket, and I soldered in the pins for the push button switches. So as you can see, I've got them soldered in, but there's very few connections yet. So I thought the next thing I would do is show you how to make a connection. What we're going to do is we're going to put in one of the I'll put in the red LED and the 330 ohm resistor to go with it. So what I'm talking about here is coming off of the IC, we need to go into a resistor R5, which is 330 ohms, and into diode 1, which happens to be the red LED. We're going to use the leads on the resistor to make the connection to the IC, and then we're going to use the lead off the diode to come back here and make the connection to the resistor. And remember that this bus down here, this ground bus, is already part of the board, because we checked and one end says VCC and the other bus says GND. So I'm going to take the 330 ohm resistor and I'm just going to bend the leads right over, right at the case, and then I'm going to put it in to the board, and it goes in down at the end here between this hole and this hole, and just slide it in. And if it won't quite go, you could use your needle nose pliers and just give it a little pull from behind. And remember, you want to get these resistors so that they're in flush to the board, so you don't want this end sticking up higher than the other end. You want it to be centered between the two pins, and once you start putting them in so that you can read them orange, orange, brown, you want them all to be in the same order so that you read the digit multiplier and then tolerance. So once you're happy with the placement of your resistor, we'll turn the board over. And what we want to do now is we want to make the leg of this resistor come down and join the first pin. So bend the other one out of the way here. And check the top to make sure that the resistor is still flat on the board. Then take your side cutters and just snip the end off. And then remember, if you've got a long fingernail, you can reheat the pad and push the wire down. And then you got to hold it and wait for it to cool. That'll be your first connection of the resistor to the IC. The red LED has to go into the 5th hole over, so 1, 2, 3, 4, 5. Remember, you want the short leg in front, the long leg behind, and it'll just go into the hole like so. And you want it to sit flush on the board. So then turn it over. And remember that the bus along here, so the first leg for your LED here, the short leg for your LED goes into the front bus, so we just need to solder it into place. Run the tip up the lead. Turn your board over and make sure that the LED is flat against the board. And you can cut the lead off at the top of the solder joint. Now don't throw this lead away because we're going to use it to make other connections in the board. Now this lead for the LED is going to make our connection to the resistor. So the resistor leg, you can straighten that up, and if necessary use your needle nose pliers to straighten it up and pull it through. And then we'll solder the other lead for the resistor into place. And you can cut that at the top of the lead. So save your resistor lead to make another connection. And now what we're going to do is we're going to bend this LED leg to make the connection to our resistor. So what we're going to do is we're going to bend it over. And we want to keep it straight in line. Okay, so it's going to follow this row up, and then we're going to bend it so that it comes over and makes contact with this resistor. So I'm going to use my needle nose pliers, and then I'm going to bend the lead. So there's my lead. Now I'm going to snip it just at the resistor and save this little piece of LED lead. You might need it to make another connection. So now what I'm going to do is I'm going to press it down so that it makes contact with the resistor lead. So I'm going to reheat that resistor lead, push the LED lead down so that it goes into the solder. Then remember to hold it into place and then let go. So now we have the pin from the IC socket connected to the resistor lead. The other side of the resistor is now connected to the LED lead, and the other side of the LED now goes to our ground bus. So I've now got most of my components mounted on the board. One thing I've got here is a speaker that's kind of flopping around here. So what I want to do is I want to make a couple little L brackets or L pins just to kind of hold it into place here. So what I'm going to do is I'm going to take some of these leftover little pins and I'm just going to bend them into a little L shape. Now I don't want to cover too much of the speaker when I do this. I use the component leads because they're a little bit thicker than a wire. And what I'm going to do is I'm going to take these and I'm going to place them around the speaker. So you're going to need at least 3 of them. Try and center your speaker into an appropriate place. And where you put them through, you want to make sure that there's no lines underneath. So here looks like a good place to put one. You can see if I solder it into place, it will just hold the speaker there. So what I've done is I've soldered in 1, 2, 3 little leads. I used the spare leads from the LEDs and just bent them over and then soldered them in underneath in 3 unused pads. One thing I would like to mention here, it's very hard to see, but these lines, right, they go underneath the IC. So from this pin it goes underneath the IC over here to this pin and then out. But it also continues on down here and along here and goes to this switch and the other side of the switch and over here, this side of the switch, over here, and over here, and out the other side of the switch. And you can see it's from the voltage regulator. So it's the 5 volts from the voltage regulator actually goes to all of these switches and then comes around and goes to power the chip. 2 pins on the chip and then over to the resistor and the capacitor. So remember to do these lines underneath the chip. The other thing I want to mention is the switches themselves. Once the power comes into this side, when the switch is pressed, right, it makes contact this way. So anything that goes on this side shows up on that side. So from here it shows up there, so I don't need to put that piece of wire in there. So I'm going to show you what that looks like on my board. So I'm going to try and show you both the board and the schematic at the same time here. You can see this is the ground trace, and okay, so this is the ground trace down here. This one right here is the resistor, right? So this is the switch right here, these 4. Okay, so this line here, which is the power line, comes in and goes under the resistor, right? So that would be this line here, comes in, goes under the resistor. I only need to solder it to 1 pin of the switch because it comes out the other side. So I only need to solder it to this pin. It will come out this side, then I have to run the jumper across. So that's my jumper right there running across. It's difficult to see, but if you take a look at it a few times, you can see that the power comes in through the switch, jumpered across, through the switch, jumpered across, through the switch, jumpered across, through the switch, and then down and around and up to the voltage regulator. So this is my finished Simon game. I'm going to take the battery with the 2.1 millimeter plug on the end. I'm going to plug it in. And the speaker is really quiet. When it's in an industrial setting like we're in here, you're going to have trouble hearing it, but if you bring it up to your ear, you should be able to hear it playing. And all the lights should play a little tune. I believe it's Hey Jude from the Beatles. Now if you press one of the buttons, it's now going to start playing the game. So one light went on and it wants you to repeat it, and if you don't do it in enough time, then it'll time out and tell you that it's wrong. The IC is already programmed for you, and you can see I put a little white dot on there to remind myself that it has been programmed. So, troubleshooting. The IC is a PIC chip that's been pre-programmed for you. So one of the things you can do is take the IC out of the socket and check between pin 5 and 14 and see if you do have 5 volts there. The voltage regulator takes the 9 volts from the battery and turns it into 5 volts. So that would be one of the first checks that you can do. One of the things that you can do is you can see that all these LEDs go to ground. So you could take a small jumper wire from pin 14, which is 5 volts, and run it over to pin 13 and see if the orange light comes on. Run from 14 to 12 to 11 and 10 to see if each of these lights come on, and that would tell you if one of these lines was not hooked up correctly. To test the switches, you can see the switch, when it's pressed, it makes contact with 5 volts. Otherwise it brings the line down to ground. So you could take a wire from pin 6 and run it to pin 10. Right, so when you press the switch down, the LED should come on. So now you can test each of the buttons to make sure that each of those are working correctly. The speaker is on pin 18, and what you can do is you can hook up the ground pin 5 and 18 to a function generator and put in a 1 or 2 kilohertz signal and see if the speaker buzzes. If things still aren't working for you, you can try another IC in here and see if maybe the IC is bad. It doesn't happen very often, especially since I've programmed all of these and checked them before I put them in your kits. So I would basically go underneath the board and check all your connections, because that's usually where the problem's found. This is the completed Simon project. As you can see, all the connections were made with all the leads from the components, and some wires had to be added, but most of the leads were made with component leads. So next time you see a project on the internet and you don't have a printed circuit board for it, you can always use Perfboard.